Hello and welcome to another video in the series where I look at the design and the tech behind previous games that I have worked on. So today we're going to be taking a look at a game known as the Eternal Collector. So it is a game where you have a procedurally generated environment and where you are on a train that is moving through it. And your goal is to essentially get to the point where you can basically retire. So let's dive in and take a little bit of a look at the actual game itself. So this is sort of how the game actually looks and where it begins. So we have these very low poly carriages. And that's right, the controls is what I want. So very low poly, voxel-based largely carriages. They are hovering rather than moving on tracks. And there are different types of carriages. So this carriage is one that collects scrap, and scrap is the main sort of currency essentially in the game. And we can see the collection rate is varying. We can see what stuff is being collected. And from there, we also have then carriages like this, which this is a bunch of solar panels. So when it's during the day, we collect energy via sunlight, and we can see solar irradiance, and that changes throughout the day. That changes based upon the weather. We can see our power usage, which things like these siphons use power. The actual engines themselves also use power. If we go to here, this is our storage one. So we can see how much scrap we've actually already got stored. And once we hit full storage, then we actually can't get any more until we expand our storage. This is where we have a shop that comes in. So there are upgrades that we can actually purchase for all carriages. We can also purchase specific ones for our battery carriage, which is what this one here is. This is a whole bunch of batteries. So we can purchase upgrades for things like of that. We can purchase upgrades for if we actually have a booster carriage, which we don't currently. There are miscellaneous upgrades. We can expand the length of the train as well. So there's a few different things that we can actually be buying here. Our siphon carriage has extensions, but storage, that's actually probably a good one to buy initially. So we can purchase that. Now, it does take a little bit of time for purchasing things kind of intentionally. So that's purchased our storage upgrade. So we can see we've actually got more headroom for storage there. Now, we can also see that we're currently losing power a little bit. And our storage one, this carriage has actually increased. So you can see it was fairly low, but there's a visual change that's actually happened here now. And if I go and shop-wise purchase an upgrade, for example, for our solar one, which is that carriage there. So if we look, you can see how it looks. And if I purchase the upgrade for it, it'll take a little bit of time. That's an intentional delay that's built in there. So that's done. These are now more efficient panels. So we should have a bit more headroom on our actual power usage. We should have a bit more power storage. And I can adjust my speed at any point. And our visual effects there for the speed, if the controls, if I go to those, no, not the shop, controls. Sometimes it's a little glitchy. Didn't used to be, but I did do a Unity upgrade for this. There we go. So I can have us go faster, which when we're going faster, we'll collect scrap more rapidly, but we use more power. Now, our batteries aren't depleting currently, so we can probably go faster again. We've still got a bit of room there. So we can see our VFX are larger there now. We have more bits of scrap being pulled in. You can see it's only managing to pull in small bits of scrap though. That's, again, part of the intentional sort of balancing of this, that there are, if we go to the siphon carriage, then the inside is upgrades here that actually allow us to expand what we can actually be doing there in terms of pulling in larger objects. There's various things here like our emergency retrieval systems. We have lightning rods, and the goal that we're working towards is this retire one. So retire one is very, very expensive, but once we have enough for it, we're actually then able to do that process, and we can happily retire. Now, obviously, it takes a while to actually gain a lot of the scrap, but I do have cheat commands that I set up for this. So I believe I can do gimme scrap, and I think I can give it an amount. Yes, I can. So what I can then do, I go to the shop, and let's upgrade one a fair bit. So we'll upgrade our solar one. That might be enough where we actually get a visual change with it. I don't remember if that one has a visual change. Looks like no. But okay, I need more. So if in doubt, just cheat. See, now that might now be the level that there's a visual change. There we go. I knew there was a point where it actually has a visual change. So it has now stairs up to here, and we can view from this upper level. And all of these carriages, whoops, have visual changes like that. And also, I didn't purchase the upgrade that rescues me when I have gone and fallen off of the train. Kind of a good reason why I should have purchased that one. What I can do, though, is I will upgrade my storage carriage a whole bunch, and that will take a little bit to apply. I will also purchase an upgrade that rescues me if I fall off. And there are safety rails that are a thing that can be purchased as well. So that's good. We've got a lot of storage there now. We'll just get a few more extensions for this, just so that we can actually see how that looks. Let's get the emergency retrieval system because, yep, that's definitely a thing that I need. And some barriers so that we actually have some safety nets here. So you can see those appeared. We can purchase then upgrades for things like our siphon. And what that will do as we upgrade the siphon is we'll be able to pull in larger items and faster. So there's some intentional stuff there where the faster you're going, the harder it is to pull in scrap, but that is reduced as you get more upgrades. So there's an intentional sort of balancing act there of trading off of which upgrades you're wanting to prioritize. So there we go. That's got a lot more that it'll be able to be hauling in. And the engine, we can upgrade it as well. And so as we upgrade it, we'll actually go faster. And we eventually can get to a point where we have much, much, much bigger rocket engines powering this. I think that's the final upgrade. Does that. Go here. There we go. So we've got much bigger engines there. So there's a lot of different upgrades for the train as a whole, for all of the carriages. We have slots where different things can actually be connected in. So let's see it with that. But if I pause it, then we'll be able to actually see it, because what I can do, if we take a look at the world, this is what we actually have generated. And we now have our retrieval system, and we have things like these lightning rods, visual changes that happen for all of these. We can see the stuff getting drawn into that. If I bring the game view down there and resume this, we can see we're moving pretty rapidly, and we can see the stuff getting pulled in. What will happen now is I'll have actually run out of scrap together. But if I zoom out so we can actually see what's happening, as the train gets to the end there, it's generating further parts to it. So we've got a procedurally generated environment. The challenge with this is there are actually biome changes that can happen. And so it needs to be trying to blend these sections together as seamlessly as possible. Now, it isn't perfect. We can notice that there is a bit of a discontinuity there. It tries to blend them as well as it can, but there are obviously limits into how well it can do that, especially when we have so many items in the environment. So, in terms of code systems for this, there is a lot. Is the simple version of it. There is a lot of bits and pieces to this. This one took a long time to put together just because of how many systems there were in it and how much needed to be assembled to actually make it work. So, and a bunch of this code I will be making available. This Eternal Tracks thing is probably a good sort of example one as a bit of of how I was setting things up. So if you take a look, I'm going to close all of the other tabs. So all of this generation stuff I will make available. But so what it's doing from a generation point of view is it ends up assembling these track tiles. Those all have information on them in terms of their actual sort of mesh. They have details there for the visual effects. So I'm using one of the scriptable render pipelines for this. I think I'm using HDRP. Pretty sure. Makes sense for me to be doing that. Check. What's the camera say? So given the sky and everything, yes, it would have to be HDRP that I'm using. I'd be surprised if I wasn't for this. But yeah, it would be HDRP. Yes, HDRP is being used for it. That's what I thought. It's been a while, but I was pretty certain that I was using HDRP. So I have everything I need there for setting up post-processing for visual effects. So there's a lot of different weather scenarios that can happen, and those do have gameplay impacts, mostly on the solar light that we're actually sort of getting. So that amount of energy we get if it's really bad weather is going to be significantly lower. So I store details as far as the direction that a track is coming from. So we have entry and exit directions, we have track types, which are very straightforward, and just keeping track of a bunch of basic sort of things. So the tile itself has a couple of things that it needs to do, but mostly what it's doing is generating details as far as these locations of entry and exit points. And if it needs to generate sort of additional ones there, then it's able to actually do that. If it's a angled point, then it actually has some calculations that it's performing there for figuring out distances and all. So a little bit involved, but this is part of how it helps it move smoothly along the track. It can clear any scrap that's already there, because obviously once we're past it, we want to get rid of it. The scrap is actually attached to this. We can pick random ones, and there's a couple of little helpers there for actually drawing the paths for the particular tiles if we select them. We have track segments. So track segments are a little bit of a higher level abstraction that sort of keep a record, keep accounting of directions, things like of that. Those are a higher level. So the track tile is the actual in-world object. This track segment is purely just holding data and information. We have configurations for biomes that affect things like object placement, the height generation. A lot of the structure of this, if you've seen any of my procedural generation ones, particularly for terrain, this will be very familiar to that, because it shows that sort of process for generating those terrains, and in this case, blending them together. And then the actual generator itself. So this has options in terms of resolutions that we're generating it at. It doesn't use a terrain object. It's purely a mesh. So it's procedural generation of the mesh and procedural texturing of that mesh as well, based upon the biome information. So we have our different sort of segments for track that we can pick from. It's a lot of sort of bits and pieces here for this. You'll see some audio logic that is hooking in here. Obviously, the audio engine code I can't distribute because I don't have a license to do that, but I'm using WWise for this. Really great tool. I'm a very big fan of it. I highly recommend making use of it. For this, because I'm doing a lot of constant creation and destruction, I am making use of Unity's object pooling system that just sort of keeps that process of creation and destruction a little bit more memory efficient. I'm not going and churning lots and lots of memory there, which is handy. There's a lot of helpers in here in terms of generating track segments, things like of that. I created some debug tools for spawning ones and for controlling things like selecting biomes. So a lot of little bits and pieces there. And then the actual generation of stuff gets controlled from here. And there is then a lot of things here related to actually blending and pooling things, because tiles have to be blended so that they actually visually link up from a height point of view with the neighbors. We try to blend, smooth out the terrain so that's a smooth join as possible, because we can easily have harsh joins, but we want to have smooth joins there. We have stuff for just a direct copy of edge vertices. And the smoothing has, ranges that it will actually try and do the blending over, and that it will try and have it as seamless as possible. That obviously can get quite tricky in some cases because you do have areas where it will generate a U-shape. So you've got quite a few different tiles that need to be blended there. It does try to do the same for color as well, and again can transfer color information. So we've got a lot of logic to actually try and smooth things and to have those blends look as realistic as possible. But then we want an area for the actual train to be moving through that's fairly consistent and fairly regular. So it also does a flattening process to actually generate that path. So it procedurally generates the environment and then procedurally flattens the middle sections of those tiles so that it can actually have an area where the train is reliably not going to be clipping through anything. And then there's not too much needed for the pooling. The actual mesh generation, I've shown logic like this before. It's a fairly similar process to other ones that I've done. So nothing particularly different there from other ones. It just is the blending that was the biggest sort of addition for this. As far as how movement worked, movement of the train and having all of those carriages there, that was actually one of the trickiest things to get working. And I iterated on a lot of different approaches for this because I wanted everything to be able to actually move, in sync. But I didn't want to have, a direct sort of hard physical connection there with them. But these things are moving over a long period. And so I did a lot of initial experiments where I would position each carriage relative to the one before it. And that mostly worked over short distances and over short time periods. But over long time periods, what I found is that small errors could build up. And because each carriage was based upon where the previous one was, if you had 20, 30, 50 carriages, it wasn't just a case of each one gets a consistent, roughly, amount of error building up over time. Error in the first one compounds in the second, compounds further in the third and the fourth and the fifth. So by the time you get to the end carriage, you don't have, just maybe, 10 minutes worth of error built up. You have 10 minutes worth of error multiplied by however many carriages were before it built up. So they would start to spread over time, or if you were on a carriage, it would be jittering around a lot. So it was very tricky for getting that moving. And what I ended up doing is how it works is each carriage actually moves independently at the exact same speed. So there is no jitter when we're doing that. And, well, at least if there is jitter, they all jitter exactly in sync. So there is no compounding error between the carriages, and it means that there is sort of no issue with growing error over time. The world generation also routinely loops back on itself, so it never strays too far from the origin. So I don't need to deal with potentially having things like a floating origin point or stuff like that. I'm able to just have it move continually, and it's never going to go so far away that floating point error from being too far from the origin will be a factor. So those were sort of really the trickier things to solve, was getting those tiles blending nicely, getting the train carriages actually moving nicely, because you can add carriages. you can do that at any point in time. So I needed to continually be able to add ones. So there was a lot of stuff to have to set up there for this. And so you'll see there is a lot of mathy related helper functions for finding particular locations on the track. I even set up like some custom vector2 int extensions just because I was doing a lot of stuff with vector2 ints. So a lot of bits and pieces there for just the actual track generation side. And there's modifiers here for the biomes, for placing objects. Those are very similar to the ones from my biome-based terrain generation. Probably of more interest is in terms of then with the general sort of scripts. The actual core logic, again, there is a lot, as we can see, to this. There's a lot of different things it was doing, because this does also have save game support. So there was logic here for putting stuff into a saved game and for then retrieving things from that. With the movement, the logic for moving along the carriages, when we were doing the carriage positions, it was all pretty straightforward for actually updating things. It would recalculate things, it would know the current tile, it tracked our distance in that tile. So that was information that I was putting together there of, okay, exactly what is the distance of the path. And I was essentially building a curved path through those tiles. And my speed of the train, I worked out how far I'd moved along that tile. And then that allowed me to see, was I over into the next actual tile or not, and could update that distance and then could update all of the other carriages after that. So kept it easy. So had logic for being able to spawn in additional cars. There was also a sequence to where things actually happened. So we needed to be updating things in terms of, if we go to our actual late update and update. So go to update itself, because it was a very particular sequence that I was going for with this, just to actually ensure everything happened at the right rate. So there was things like if you got hit by lightning, then you could get a bit of a speed boost and you would get a bunch of energy extra. If you had purchases, it was tracking those and could unlock upgrades or spawn cars. It would refresh visual appearances. Had some debug stuff for adding in cars and upgrades. That just made things easier. So this was one where probably one of the first ones where I needed a lot of debug tools just to actually test everything. So carriages would go through and update power usage. They'd refresh their stats, and we would then tick the actual carriages themselves. So the individual carriages would have logic that they would be applying. And power, we would track requests and we would track storage. So firstly, we'd figure out things like, okay, well, how much energy do I have stored? How much power do I have that I can potentially store? We'd update based upon requests, and then we'd redistribute the energy. So the redistribution just handled the fact that each individual carriage didn't really need to track its own sort of current energy level. What would happen is once we'd actually applied budgets, everything would get leveled out across all of the carriages. So the individual amount of energy stored by a particular carriage might bounce up, but then you'll never see that because it will get leveled off by all of the other ones. So that worked out quite nicely for handling sort of the general logic there. In terms of what the actual carriages did, because a lot of the rest of the logic here was for things like movement, and just like we redistributed energy, anything stored, we did the same. So that was done for scrap as well. And then movement was done in late update. Now, in terms of what the carriages themselves did, they generally didn't need to do anything too fancy. So our base carriage had a lot of information in terms of positional stuff, where head is, tail is, where the player spawn point would be for it, your camera locations, bunch of different things there that we could be sort of storing. Stuff for visual effects, and it had a behavior link to it. So all carriages used the same prefab, and if we go and take a look here at this carriage prefab, it actually has the visual assets in it for everything. But what it also has is it has this component map, and it maps from a path, and that's the path in the hierarchy here, and it has meshes for different LOD levels. So I was doing lotting of the actual meshes shown based upon how far away we were. It had, for particular things, so like lower floor, could be used by all of these different carriages. But if I went for something like the solar car level 1, well, that could only be used by the solar behavior. So different sort of setups there. We also had things like, okay, well, our emergency retrieval system, that had markers that were linked up, so return points. We could also set visibility rules. So this was the thing with procedurally assembled carriages. I needed a lot of rules here, essentially, for controlling, okay, well, what things could be present. So in this case, for the emergency retrieval asset to be visible, we needed to be one of these carriages, and it needed to have the emergency retrieval upgrade present, and it needed to be at the tail. So a lot of different sort of ones there. We had similar things for like of the lightning rods. The lightning rods needed to have that upgrade unlocked. They had the specific behaviors. So that was for the lower ones. The upper lightning rods, they had further markers and things like that. So we had a lot of different upgrades here to actually work with. The UI as well was only supported in different carriages. So this was, again, one of the biggest sort of challenges for this, was having this prefab and then applying all of the actual rules to change how it appeared. So a lot of the logic in our carriage here relates to being able to do that unlocking. So all of my visibility rules and comparison logic is relating to that. Most of the rest is for switching LODs. If it needs to, it keeps track of if the player is there or not, and that would affect which ambient audio was actually playing. Could synchronize visuals for when we unlocked upgrades. But the actual most of the logic for what a carriage did, that sat within the behaviors. So like of our storage ones, didn't really have to do much because they just had these storage capacities, and upgrades had effects. Again, I built a lot of systems for this, so it did a lot of things. Solar was a similar sort of setup. It had a little bit more in that when it was ticking the power, it could check things like, okay, well, what's the actual irradiance, the light level? And that would then actually, and I was using actual formulas here for it. That was one of the things I did with this, is I took largely real world values for things like engine power, mass, for stuff like the amount of solar energy that I would gain. And the reason being is that it made actually the balancing a lot easier, because things just largely worked, because I could make sure it worked from real world ones, allow a bit of a margin of error with that, and it was pretty much working reliably. So that's why a solar one, it works off of essentially the solar panel area. And as you upgrade things, it can change stuff like the solar panel area. Or it can change the efficiency, and that all cascades to give us the amount of energy. Siphons probably the most complicated one, because it has a lot of logic for its updating power based upon how many things it's tracking. But then it's actually doing a lot of logic to find things to siphon. And we have small, medium, and large siphons. And there's different objects it's trying to pull in. So it's scanning for targets and trying to track them. So it can lose track of stuff. And that's intentional. As you are going faster, as I said, it makes it more difficult to actually collect the scrap. So there's a lot of bits to this. Things like our engine booster had very little logic because it was largely just an engine. And even the engine itself really didn't need to do a lot of stuff. There was a couple of things for supporting upgrades and just for setting speed. Battery as well, very little logic that it needed. So a lot of the stuff for those systems had very little setup, but it allowed us to do a lot. So if we take a look at things like the behaviors, these would have descriptions, they had base stats, they had audio hookups. That would vary from 1 to 1 of what things might be available. And all of these descriptions would get shown in-game. The upgrades were similar. So it made balancing and adjusting these upgrades really easy, because I could configure, okay, well, here's the prerequisite that needs to be present and the effects. And I had control here of, okay, well, what parameter was it targeting? And how was it affecting it? So it could be adding or scaling or setting, and the amount. So it gave me a lot of flexibility with these upgrade systems for being able to impact what they were actually doing. So it made that process really, really handy for setting stuff up. So that was definitely something I would carry over to further ones. And these had a lot of markup, and this process of having these positioned, naming mattered a lot with this, because I actually had some helper stuff here to rebuild the carriage data, which would pull in all of those meshes and allow me to remap everything. So setting up editor tooling, things like that, made a big, big difference with this. That was sort of one of my big takeaways, especially from a point of view of balancing this. Having this sort of setup with these easy upgrades, controlling what each one would do, meant that when I was playtesting, I'd find things like, okay, well, the top upgrade for battery for that sort of feels a little low impact. So I want it to be more impactful. So I would add in things like, okay, how much, adjust how much more it's weighing the train down, and adjust how much it's scaling the capacity by. So it made tweaking and adjusting things there a lot easier. But I also had essentially difficulty modes. And we had these game mode presets. And it was possible to add in additional presets here. And this was because the game, I kind of wanted to give people a bit of variety of how they might want to actually have it. So they might want to play it at the default settings. They might want to play it at a, resource poor stage or a resource rich stage. So I set up these presets, and they would control things like, okay, what is the scrap cost per unit? And if you look at something like an upgrade, these costs, those are in units. So I never specified the cost in the actual total amount of scrap, I went for setting it in terms of these cost units so that from a balancing point of view, I didn't need to rebalance the cost of every upgrade for each different mode. What I could do is I could balance the cost of the upgrades relative to each other using those essentially cost units. And then in a game mode, I could adjust what that effective cost per unit was to be able to make it easier or make it more difficult. So the default, it's a translation of 150 it multiplies by. Whereas the fast mode, actually the cost is 125. So it means that things are much cheaper in fast mode. In slow mode, the actual cost is 200. And I also adjusted things like the initial scrap stored, the initial energy percentage, and there's some biases that I added there for the amount of scrap that you gain. So it just gave me, again, from a difficulty point of view, I had kind of 3 different difficulty or experience levels, but the configuration was all in one spot and centralized controls. So those really made my life a lot easier from the balancing point of view. And it meant could get a solid balance for the default mode and then easily make that more difficult or make that much easier based upon just a couple of simple scaling factors that I had all in one area. So really, really useful in that regard. So I think that really sort of covers the majority of it. There is a lot of systems here in terms of, managers that are tracking stuff like time of day and season. I did have logic for different seasons, and they would have different events that could happen. So I had a whole event system that could kick off, and you would see details of what events were happening. These could inhibit others. They could have durations. They had a variation of intensity. They could do different things like locking out particular stuff. So they'd inhibit other events. They could have it that they couldn't coexist with certain ones. So some of these you could get happen at the same point in time. And they were tied to different seasons and everything like of that as well. So a lot of different systems. That really was the big thing with this. Is I focused on, I wanted to be able to have an experience that largely could be pretty chill, but I wanted there to be the interesting challenge to be gathering and collecting stuff and choosing what upgrades you were wanting to get when. That was really sort of a big part of it. And I'm pretty happy with how it worked out because you can actually get pretty large trains. So one of the final things that I can do just to sort of demonstrate is I can come in and I'm going to unlock all of my upgrades because that's always handy to have. Nothing like a few sort of cheat commands for it. It's always quite useful. So that's good. I can see those, so I should be able to go much faster. And I can say, give me scrap. I'm just going to ask for a huge amount. Because then what I can do from a shopping point of view is I can buy some further carriages, which in this case, I think what I will do, so what do I want to get? Not siphon carriages, I want to get some more storage ones. The cost of these does also increase as you have upgraded ones. So the more upgrades you've purchased for a carriage, the more the initial cost of it is. But I now have a huge amount of extra storage. And I can purchase even more. So we'll just get multiple carriages. Should possibly give me enough. We'll see. Way more scrap. So I nearly have enough to actually afford the retirement option. Because I want to show what happens when you do the retirement option. Okay, so that's purchased. So now I've got enough to, under miscellaneous, we've got everything, so we should actually already then have. So when we go to and have purchased the retirement one, we now get a set of stairs. We can walk up to the top here. We've got our little sort of area built, and we can select to retire, and we can just chill and essentially watch here. And from memory, what will happen is it does then fade out like that. So that's sort of the core of the game. Now, as I said, there's a lot of pieces to this. There is a lot of code involved in this. I'm going to be sharing as much of that code as I possibly can because there's a lot of systems there that I built for this. There's just, a lot of bits and pieces. There's even a save load system, things like of that all in there. So I will make that code available so you can dive on in and take a look at it. And see what bits of that you might want to use in any of your own projects. So folks, hope you found the video interesting and helpful. If you have, check and like and subscribe. It really helps out. It's really appreciated. If you're looking for the code from this, as I mentioned, that is going to be available up on GitHub, and there is a link to that in the description below. You can use that code in any of your own projects, commercial and non-commercial ones. If you have any questions, chuck those in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon or YouTube Super Thanks are enabled, so either of those are there as well. But until next time,